Hello, with us today we have lecturer and trainer Mr. Kris Schermerhorn. Kris has a degree in dental technology and presently owns and manages a full-service dental lab in Virginia. Kris first began working with acetal resins and other thermoplastic dental materials in 1996. He was also named Inventor of the Year in 2007 by the NADL. Due to Kris's expertise and experience, he has served as a consultant and resource for Zahn for many years. And without further ado, here's Kris Schermerhorn.
All right, guys. Well, thanks for joining. I'm really excited about this material. It's used in so many departments in my lab. Acetal resin I've been using since '96, but we injected it. And this material has a good bit of shrinkage to it as it cools. And that was a hard thing to manage. Well, now that we're able to mill it, that goes away. And that opens up a lot of opportunity with this material. So what we're going to do is jump through a PowerPoint, kind of showing you step by step how to do all the different appliances you can do. I mean, there's so many different things from the fixed side to the removable side. And then we'll jump into maybe doing some quick designing of some frameworks just to kind of show you, reiterate what you saw in that PowerPoint. And then we'll follow it up with some questions. I have some samples here to maybe help answer some questions, and we'll roll on from there. So let me get my ugly mug off of here, and let's get to some good stuff. So first thing to understand about acetal resins are they're tough stuff. This is not an alternative to PMMA. This is not, a little bit better than a plastic like PMMA. This is a lot better. You see here nuts and bolts that are made out of these types of acetals. You have over here, this is the recoil spring from a Glock semi-automatic handgun. All right, this is what most of our police departments use. And there's a bushing in there that's made out of acetal resin specifically because of its impact and wear resistant. All right, we'll talk about this list here as far as the friction, which means it wears very well. The moisture absorption, there's almost none or as close to zero as you can get with anything. And the dimensional stability. This is a piece of acetal resin that's in an engine. All right, you'll find in any research you do that acetal resin is used in the harshest environments. And so with this yellow piece is a piece of acetal. A couple things you'll notice about this picture. This is a drop of oil. This sat in oil for 40,000 miles and nothing absorbed into it. So when we talk about having zero absorption, this is a perfect example. I'm a bit of a gearhead. I like to wrench. I have a 50 Mercury and I have a 66 GTO, and I like to get my hands dirty. And that's exactly what happens when you work with oils and greases. I'm cleaning my cuticles out for the next 3 days. This sat in oil for years, 40,000 miles worth, and absorbed nothing, kept its color perfectly fine. Also, this is what's called a tensioner. So this is spring-loaded, and this pushes on that chain, keep it from having any slack in it. You have your drive shaft and your camshaft connected by this chain. So again, you can barely see a notch that was worn in that plastic, just a slight notch. Now, it's in oil. That's a lubricant. That helps, but it still shows you that wear characteristics of this material is outstanding. And not to mention also that this is a Harley-Davidson Screaming Eagle engine. And this is an air-cooled engine and, works well over 200 degrees very often. Harleys run pretty hot. And so this material also can handle a lot of temperatures, which is nice because you'll see we're going to be applying acrylic to these, and that's going into different modalities of curing it, which some are boiling, which is fine. So, tough stuff. The reason I talk about this is, I want to make sure that you guys understand that, it's not just the dental industry that's using this plastic for really harsh environments, really tough stuff. Other industries are as well, so you can have confidence. So a couple of the types of appliances you can make with this plastic, this Zirlux Acetal. is kind of, I mean, I'm going to show you some, but you'll find in the lab you'll be using it for all kinds of neat and different applications. One is something as simple as, a preliminary type of a try-in that the patient could take home and wear. Let's say you're reestablishing a vertical. The doctor establishes that vertical however he does, sends you that bite, and you open the patient into that position, and this will slide over their existing teeth. It doesn't take any prepping. It's not cemented or use any kind of adhesive to hold it in place. It is just slides over, which allows for, I'm hearing music. Allows for retention just by the flex of the material over the lobes of the teeth. We're also going to show you how to make bite splints. Again, you got the wear characteristics, the strength of it, the health of it, and you're going to have the partial frames. So this is something that's very unique. This is something that's, you're just like metal, right? Except for no metal. There's acrylic. This is regular acrylic. It's going to be applied to the saddles, and so you don't have any much of any difference in what the doctor's used to. So how do you get started with acetal in your lab, the Zirlux Acetal? Well, we'll talk about later, you don't necessarily have to have a mill. You don't even necessarily have to have software to design a partial. There's plenty of options for you to be able to get these made. But if you do have those, that's great. And we'll talk about how to get rolling on that stuff. And we'll talk about, and we'll show you a couple cases that we've done in this material in the patient's mouth. So let's talk about the Smile Composer. Exocad is one of the softwares you can use. Cool thing about it is just about any software that's out there that you can make a crown with, you can make one of these. You're going to have some workarounds with different softwares in different ways. What I found specifically with Exocad is just marking each tooth as if it's a prepped tooth, even though it's not. Telling the software that you want to make a fully anatomic crown that's splinted together. So you can see we have these marked as full anatomics. We mark them as splinted together all the way around. And, I find a lot of these, you got to be careful. If you're doing it strictly or the doctor's doing it strictly for cosmetics, you got to be careful with that. These are plastic. They are tooth colored. If the patient's badly stained, badly chipped, broken down teeth, you can make a dramatic difference. Really aesthetically, you can make a dramatic difference. But if the patient's already somewhat cosmetic and, it's kind of, their mindset is, well, I could spend $15,000 on veneers, or I could spend $2,000 on this. Well, that's not a comparison. Veneers are going to be smaller. They aren't going to affect the speech near as much. There's something that it is, that it requires that price to get that cosmetic look. This is something for patients that are far beyond healthy, but far beyond something like that is a nice cost alternative. Beyond that, opening the bite is where I think the sweet spot is with these appliances. When doctors want to reestablish a vertical, a patient's really worn down their teeth, are thinking about spending $20,000 or $30,000 on something to open that bite permanently, but are unsure. This is a good way of having them try something in, making sure that any pain they may have is helped from this open position, and allows them to, try it, and gives them confidence that if they spend that much money on a final, then, it's worth it. So it's a stepping stone, I think, in a lot of instances. So you're going to mark your margin. Nothing special with marking the margin, except for you want to have a gap between. So you want to make sure you have space there. You don't want to even come close necessarily. I mean, this is only probably a millimeter of a gap. It's zoomed in, because we are going to connect them, and sometimes it'll glitch out the software a little bit if you put it too close or even overlap it. Another thing that you want to be wary of is, as you mark the margin, back off the picture of that appliance, right, on the screen. Back it off and look down and make sure you don't have any major path of insertion issues. The software is going to be able to deal with some insertion issues and be able to block those out, but there's times where it's such extreme. I mean, the software is designed with prepped teeth in mind. which there should be very few instances of undercuts, if any at all. Whereas with this, there's going to be undercuts everywhere. So you got to kind of help the software out by overextending margins down onto the tissue so that it can deal with those, and then you can finesse those back and grind them back during finishing. Also, previously even scanning your model in, consider blocking out with some wax. Consider taking a look at some major undercuts and helping the software out a little bit by blocking those out before you actually load it into the, get the scan in. Once you've marked all your margins, as you can see, I'll extend, you can kind of see the outline of my margin here. I'll extend on the lingual, for strength as well as to help the software deal with any undercuts, a few millimeters below that lingual margin. On the buckle, I'll go right down the margin. I'll slightly overextend it so that I can finesse that with a handpiece after the fact. I think you'll find that, during design, it's going to do some goofy things. It's going to be somewhat problematic for that software, but you can actually work with that, as far as blocking out, overextending margins. You can really help that software out. Nothing special here. I actually find that when you choose the full anatomic option, having a dye spacer there is nice. We want to have retention, but having it down just at the neck of the tooth is a nice thing. Not having it, totally encompassing that tooth. Patients will tend to have a little bit of achy teeth if it's fitting kind of too tight. We're having so many points of retention, 12, even 14, 16 teeth possibly, that it's going to be retentive. So that's not an issue. So having that dye spacer gives it just a little bit of freedom and makes it a little bit more comfortable, I've found. So we're going to position our teeth. This one is really opening the bite. This is a real case. This is case doctor does a lot of pain management dentistry. But, I would say that if you want a minimal bite opening, that in most cases, sometimes the morphology of the patient and the bite and stuff limits this, but most of the time you can get, 0.5 millimeter to 1 millimeter bite opening is, the minimum. You're going to have some bite opening in most cases with these. So just position the teeth. You're going to have some strange spots like this. You may want to broaden your tooth, kind of fill that, and then you can kind of push it back once you adapt it to the model. Once you adapt it, you'll push bellies in, things like that. Just know you're not going to get it perfect, all right? Just know in design, don't chase your tail. Don't sit there and try to make everything absolutely perfect. Acetal resin grinds absolutely beautifully in your hands with a handpiece, all right? So don't, you may spend 30 minutes trying to get it perfect when if you left it with a basic design and get everything you need, you probably spend 5 minutes finessing some things after the fact with your hands. So, that might not be for every lab. That concept of finessing it with an experienced technician after the fact may not be an option, and therefore spend the time designing it and get it look really, really close and really, really nice, with the software. But you just decide for your lab what works for you and, go with it. I'm a big believer in your lab better than most people. Once you get to design, it's going to give you connectors. I don't spend time trying to minimize all these connectors so that I scoot all of the connectors out to the lingual, all right? Minimize them, slightly, but I don't spend a lot of time. And so I'll wind up having these bumps, these little mountains everywhere. I can literally within 2 minutes, once it comes out of the mill, take a handpiece and zip all those off. So I'm not going to spend all the time trying to shrink those down and minimize and shape and all that stuff. Scoot them all to the lingual, let them poke out. When it comes out of the mill, zip them all off. Here's my case ready to be nested. You can see the inside. We'll have blocked out some. Again, that's probably the trickiest part, is managing those path of insertion. So all the different undercuts as it relates to all those different teeth and kind of getting that to go into place. Lowers are always easier. If the doctor's trying to open a bite, that's all they're trying to do, is have something cosmetic as a temporary option, do it on the lower. That's an easier one. The teeth have less undercuts. Uppers can be a little bit more problematic, but really not so much, just a little bit more difficult, a little bit more attention to those undercuts, maybe a little bit of blocking out with wax beforehand. There's our case. And so here's a real life one that's made, nice anatomy. This one, patient was probably opened up a few millimeters, probably 2.5 millimeters. This was a patient that's overclosed. You can see over here. You can only see 2-3 millimeters of their anterior teeth are so overclosed. This doctor studies under Dr. Kris and did a deprogram. Dr. Kris as a deprogrammer, reestablished that vertical, gave me a bite, and then we created the appliance here. And you can see, there's some gold. It covers up, that. It turns out really, really nice. All right, bite splints, night guards. Nothing special here. This is a cool thing. So kind of when you get started with this, you're like, ooh, I don't know about the framework. I don't know about the smile composer. Bite splints are simple because you do everything that you've already done. If you've done some bite splints out of PMMA, do the exact same thing. Just load the Zirlux Acetal into the mill instead of the PMMA. The one thing I would recommend is making your milling diameter, if your software already doesn't do it, large. So, 1.4 is a choice that I like. What that is telling the design is to not make any sharp angles because the largest burr that's going to be used on this is nearly 1.5 millimeters. Again, just like the smile composer, a bite splint is using 12, 14, 16 teeth to hold it in place. We don't have to have absolute intimate contact with every single tooth, especially in the anteriors. You will get achy teeth. Patients will have achy teeth. So using the larger burr diameter, it just rounds everything. It opens up all those sharp, fine angles, and I think you'll find you'll have a nice retentive fit, but passive. And, other than that, if the doctor sends you a bite, if not, open the bite, all this is the same. With the Zirlux Acetal, 8 to 10 times stronger than the strongest PMMA. You can make these smaller, lighter, daintier. So if a patient has gagging issues, you can make it much smaller. That's a big advantage. It doesn't absorb moisture, so that's going to stay clean. It's not going to stink like a lot of PMMAs can. And then, of course, those wear characteristics you saw in that Harley Davidson. If you have a patient that just destroys night guards, really help the doctor get the patient into one of these. And I have doctors who have patients that go through night guard within a week or two. And once we get him into one of these, it's a year later, and he's sending me pictures and saying, not only hasn't it started to wear, but there's shiny spots where the cusps are touching. The only time I've seen a patient go through an Zirlux Acetal night guard or bite splint was, doctor called me. He's like, yeah, patient wore right through this. I'm like, that doesn't sound right. So I ran over to the office, and the patient had Crowner Bridge, full rehab on the opposing at some point. And there was adjustments done, and it was rough. It never was really shined. And so those PFMs or whatever they were, crowns, were rough. We're able to gain friction upon the material and was able to wear it. So that's the only time I've ever seen that. Marking, so your undercuts, if you make it much thinner, you can get a little flex, but I would still just follow all the same, default parameters that are set for your bite splints for your software. So going into the undercuts, I like to not go down all the way on the anteriors, like to kind of cut them in half or even less on the anteriors. Again, that's where patients will complain of achy teeth. And then kind of run it down, depending on the undercut, right down close to the gingival on the buccal. On the lingual, you can extend it like a normal, or if, bulk of material is a concern, you could probably go even right down to the gingiva on the lingual, and that would, that material is really, really strong, so that won't be a problem. Again, your undercuts, you'll get some flex from the appliance, but when it's that thick, you're really not going to have flex like you will when you're doing a clasp, like I'll show you later on. So with this, you're looking at, following the same parameters as you would with, PMMA, bite splint, or any other material. So here's our bite splint. Everything else from there is the same. That's why I like when people are thinking about getting involved with the Zirlux Acetal. Bite splints are a nice one because you're not doing anything different if you're familiar with doing bite splints with PMA. Do everything the same. Even when you load it into your CAM software and you choose your milling strategies, it's all same PMA, same burrs, same tools. I still got to get used to calling them tools instead of burrs. So everything is the same. So that's a good one if you want to get your toes wet and kind of give the Zirlux Acetal a chance. That's a good, option to try on your first go as a bite splint. And then secondarily is just a crown bridge case. So the Zirlux Acetal makes really great temporaries. When this material is thin like in a clasp, it's nice and flexible and moves. When it's a little bit thicker, right, like in the temporary bridge or something like that, it becomes just as rigid as PMMA would be, but 8 to 10 times stronger, doesn't absorb moisture, ridiculously strong. So you don't have to make a bridge and put any fiber or metal reinforcement. It's going to be plenty strong on its own. Doctors reestablishing a vertical, preps the teeth. You do a temporary, do it in acetal. You do it in PMMA. The patient could grind it down, wear it. They're going to have perpetual bad breath within a month or two if it's a long-term temporary. So really good option for crown bridge, as well. So jumping over, and I'm talking fast. I'm talking a lot because it's cool. This is the material I use in every department of my lab. So it's a cool thing to have, in your back pocket to be able to mill or really inject. But milling just solves a lot of the problems that problem had when it came to injecting. I mean, I injected it since '96. Don't get me wrong, you made it work. But there was times where you would inject something and, it just didn't work. Material shrinks as it cools. And when it's thicker, it shrinks a little more in that area. So sometimes that was really hard to manage, that shrinkage. So with milling, it's absolutely no issue. So partial frame, again, this is just like a metal frame, just not metal, right? And there's a lot of other materials that are kind of coming out and they're doing a lot of advertising. And those materials are just kind of ugly. The Zirlux Acetal comes in many different shades. It's not a stark, bright color. It's not porcelain, don't get me wrong. It doesn't have that much depth of color, but it looks really, really nice in the mouth. Has just enough flex to be comfortable, but just enough rigidity to be stable. And then you can apply acrylics, so doctors love that. They could do relines chair side. They could do repairs even attaching to that acrylic. And with the hot shot gun, which is a thermoplastic gun, it's made for, injecting the acetal, doing clasps, repairs. You can repair this material with the hot shot gun. So if you were to need to add a clasp or, let's say, you finishing it and you whack the major connector, when you're finishing the acrylic and you whack the major, put a hole in it or do anything like that happens, it can be repaired just as easy, in most instances even easier than metal would be able to repair. So mark your major connector. The biggest thing when it comes to frameworks, if you're experienced with doing frames, and even if you're not, is kind of the comparison from the default over to what you need to have. So over here we have our default. All right, so you can kind of see some of the settings as far as thickness. The computer says is ideal for metal. The software says is ideal for metal. Over here is what I like to see. So mesh thickness, all right, so this is our mesh. It's much thicker, all right? So we're jumping, a few tenths, not much thicker, just a little bit thicker, about close to 1 millimeter thick. The relief underneath so it's only 0.5 millimeter thick as far as the wax or underneath that mesh. Over here, we're looking at almost 1 millimeter of gap. That gives us a bigger butt joint for the acrylic and also more thicker acrylic. This is going to have some flex, but we don't want it to have flex in an area where the acrylic and the Zirlux Acetal are coming together. So having that butt joint thicker, that acrylic thicker is going to make that area more rigid and keep it stable. I like choosing smooth. It comes out really, really nice with a nice smooth texture. And then your base thickness here. You want it to be about 1 millimeter thick. All right. Now, if you had limited space, so if we jump back and let's say the patient could have a lot in their mouth. So let's say we really ran this major connector up, and it was only half as broad. There, you might want to jump up to 1.4 millimeters thick. But if you're a normal thickness, right? So a normal distance, about 1 millimeter to 1.1 is going to be a nice thickness for your major connector. So here's what our major connector come up after we choose. The way Acetal works is you create your mesh. I like having just large, big mesh work, not a bunch of little holes. Again, it stabilizes that mesh, makes it a little more robust, and it allows for that acrylic to make its way through and really wrap around. I'm finding that that's a nice choice, is to oversize the mesh. On 3Shape, you can create your own mesh program, or what you can do with 3Shape is make it as a solid sheet, right? A solid sheet, and then just come back with your waxing tool and put the nice big holes in. Or you could do a solid sheet and punch holes with a burr after the fact. That's up to you, but I like a nice large diatoric. So let's talk about our clasp. So these clasps are going to be flexible, but we can't just run them into an extreme undercut, right? We have to still be conscious in this area because there's going to be acrylic on here. Once there's acrylic, this clasp is going to cease to be flexible right there. So we're going to stay at or above the height of contour here. Then we can drop into a nice undercut. When it comes to most softwares, they kind of have this color code. Red is the most extreme undercut. Transitioning to orange to yellow to green to blue is the least undercut. I would say you want to stay away from red unless it's a very tip, but stay away from red. Orange is okay, but try not to make that in the major body of your clasp, just at the tip. And then if you get into the greens and blues, you can have that all, you could have 60% of that clasp in an undercut. It's fine. When it comes to your choice, you're going to have to make it larger than most software companies offer. Most software companies allow you to create your own clasp design size, so you can kind of play around with that. But choose a large clasp. But here's basically the parameters. So I've found, this is default, again, kind of a 2x2 with a 3 millimeter kind of a round width, if you will. I jumped that, so this is what this would give you at that parameter, 2x2. I'll bump the base up to 3.5, tapering down to that 2. All right, you get a little bump here. You can, again, this is not metal. You don't have to have it perfect. You can zip that and flush it right off as you're setting teeth or anything like that to help with that. But having a little more thickness there on a posterior is good. When you jump to an anterior tooth or even a premolar, you can make it a little smaller. Just bump it up a little bit at the base to 2.5, tapering down to a 2. And again, you can also finesse that tip a little bit once you get it out of that mill. You could do it with the software, and that's fine. You can kind of make that more of a point, but that's up to you whether you want to do that, in the software or do it with your hands outside. Again, you'll love how this material grinds and adjusts. So there's my stuff. I will fill this area in with wax, take my waxing tool and fill that area in, because the broader you make it in this area, the thinner you can make it. And the thinner you can make it allows you to set the tooth in there nice and intimate, nice and close up to that adjacent tooth. So you could fill that area in and then thin that out. Tissue stops. You want to have multiple tissue stops. I'd like to see 1 to 2 large tissue stops and make them 2 to 3 times the size that you would do for metal. The reason for that is you're going to be processing acrylic. Most of you may be injecting, maybe some packing, however it is, you're putting hundreds of or thousands of pounds of pressure on this frame while you're squishing that acrylic in there, and you need to keep that flexible frame stable. Metal can kind of handle that with a small little tissue stop. The acetal, we need to have more robust, more, even if you have got a tooth here, you may even put a little smaller tissue stop just to keep things stable. You can always, and it's not metal. It's not a big metal dot. It'll blend in fairly well with your acrylic. So nice big tissue stops, kind of put them, if you think you got enough, maybe put even one more. So here's our framework. Up here, I was going to do a clear clasp on there secondarily, injecting it with the hot shotgun, so there's no clasp there. The acetal resin, again, it's tooth colored, looks great, but on a front tooth, like a central, it is still something on the tooth there that's tooth colored. So doing clear is just that one step up to a little bit more aesthetic, and you have that option. You'll lock them together mechanically. this clear will just inject onto this area and lock on, and then you'll surround it with acrylic later. So here's our final. Again, I might fill that in just a little bit more so I can thin that out. This one's filled in pretty nice, so I can thin that out. CAM software, my CAM software has the option of partial framework, and that's nice. Not all of them do, and a lot of them that do not have that choice will tend to be slow. We're working with CAP to speed up some of the milling strategies so that we get a faster mill. But you're looking at something like this in my mill, which is a VHF mill running off of VHF CAM software. But you're looking at probably an hour and 40 minutes to mill this. My software has a choice of quality of mill, 1, 2, or 3 star. I choose 1. The surface will come out, you'll see, looking like it's polished, so it's not a problem. Choose framework, and you can use your PMMA tools, and as far as material is concerned, the PMMA as a choice is fine. Put your support pins. This will be flexible, so we need to put support pins to stabilize it. I keep away, if I can at all possibly, from pinning to the outside, because this material will be thin, and being thin, this can be flexible and possibly, not all the time, somewhat rarely, possibly cause an issue. So I do not, pin to that outside if I can avoid it. I pin to the tips of those clasps to make sure they stay stable. Makes everything rock solid. You won't get any chattering of the burr as it hits flexible, of the tool as it hits flexible areas, anything like that. Here it is after milling. You can see comes out almost with a bit of a shine to it. There's really not much polishing, if any at all. Usually what I do is I'll send it for trial, shape things up, send it for trying with T-set or with bite block on it, or however the doctor wants it. When it comes back, I process the acrylic. I polish everything at the same time, because pumice will polish up the acetal nicely. So you can polish the acrylic and the Zirlux Acetal all at the same time. Here's the outside. Again, this is on the lowest mill quality, and it's actually got a shine to it coming out. So it's really, really nice. So just so you know, we have 5 different shades. We are in the development to create more shades in the future. Can't give you a guarantee on when that might happen, but there will be more shades available in the future. We have a bleaching shade, a B1, an A1, A2, A35. And then it comes in 15, 20, and 25 millimeter thicknesses. And right now it comes in the the most popular, 98.5, I think it is the diameter, or the outer round of it. I'm sure we'll come up with other shapes for other mills in the future, but right now we have the most popular. So, before I start designing, one of the things I wanted to talk about, I kind of alluded to it at the start, my mill will mill this in, anywhere from an hour and a half to a little over 2 hours for a big partial. And that's a lot of time in the mill. Now, I have a puck changer, which helps, but not all of us do. And some of us are cranking out some zirconia, and to jump over to that Crown Bridge side and say, hey, guys, I need your mill for 2 hours. That's sometimes you can get some arguments, some fights on that. So one thing that you want to keep in mind is there are some people starting to mill it out there in milling centers. The one that I know of, and really the only one that I know of that's specializing in this, is the CMC. And they're very affordable. And so you could design it and send it over, and they can mill it and have it come back to you. They're even getting into doing the designs as well. You would want to talk to them about that. But, even as far as my lab is concerned, sometimes you just get so busy that you just can't find time in the mill, and it makes sense to send over. Some people worry about wear and tear in the mill as well. Hours on that mill is money, because those spindles go, those mills, it's a working piece of equipment. And so if that's a concern for you too, send over, let CMC use up their mills. and you can call them and ask about pricing. I'm not really going to talk on that necessarily. I will tell you that it's very affordable and makes really good sense. It's not something where there's much of a decision has to be made when you take into account the material cost. you know, and I'll talk about that in a second as well, but the material cost as opposed to the time, you know, wear and tear in the mill. So, you know, if you don't even have software, you know, all you have to do is get the models and or a digital file, and they can do some designing for you. If you do have the software, design it for them. That'll save you a little bit of money, and you know, I've seen really good results. So I personally did a training with them. They already kind of knew what they were doing, so they're really doing their due diligence, and that was quite a while ago. And I've heard nothing but good things. So that is definitely an option, especially with a lot of these. You know, there's some other companies are really doing some blitzes on advertising, and some of these other materials are just crazy expensive. Before you even have an end result, an appliance, the material costs you got into it are astronomical. And with the acetal, you'll find that it's very, very affordable, and you know, actually has a longer track record. I mean, I've been using it since '96, and it's you know, generally speaking, it's the same material. It's just a different way of fabricating or coming to an end appliance. So, and then keep in mind, CMC, I actually have them do a lot of my abutments. You know, they're FDA approved. They actually, one thing that my doctors love is they send a warranty card with the abutments, and they just love seeing that. And so, you know, they do a lot of other things other than the Zirlux Acetal just to help us out. I don't mill abutments. I'm not going to deal with FDA to be able to, you know, mill those interfaces. So you know, we find a nice reliable place, and I've been really happy. You can either, again, design them yourself. You have to talk to them about getting some possible scan jigs and stuff, but or you can have them design, and I've had them design some. They do a really good job. You know, that's one thing that can be lacking in some milling centers is that design of an abutment. They kind of got it. You know, I take a look at them, and I don't think I've made a change since I started doing that. So you know, it's not the commercial. I don't work for them. I have my own lab. It's just honest truth. We need, you know, milling centers like that to help us, and that's exactly why I'm sharing that. So here's the last kind of little case study. This one, patient has 3 anteriors, 2 posteriors. That's all they have in their mouth, and doctor kind of was like, hey, what can we do here? I was like, can we crown these teeth and do a partial? No. Can we do implants? No, just can't afford it. Pretty much all we can do is a partial. So what I came up with is this. So this is a little bit of our Smile Composer combined with a partial. Doctor was concerned he'd have to do reline, so we'll have acrylic here. We'll clasp here. Patient didn't make contact on those anteriors. She had to slide protrusive to make contact. But if she had, we could have put a window so that she bit through this into her natural occlusion. Here it is in the mouth, getting tried in, and then here it is with the final. So you can see, you know, huge difference. This is going to be a more expensive, I think, lab build to the doctors, more work involved. But man, what did the doctor give the patient with this? You know, could have chose, you know, just about any shade as long as it didn't clash too badly with the lowers. Gave them the partial so they can eat, you know, what they need, and some aesthetics. So it's really some cool things that you can do with the Zirlux Acetal materials. All right. So I'm going to jump over here since we have a little time and kind of show you what I was talking about. I'm going to do a little unilateral. So the first thing that we talked about with our mesh is kind of making our hole size larger. So we can either drag and make it larger, or we can actually punch it in. But I like to, you know, 4 nice big holes is good. Our mesh thickness, I'm going to up that to close to 1 millimeter. That's the thickness of the actual mesh. And then the relief is only 0.5 millimeter. So I like to take that close to a millimeter thick, just under. All right, so that's the thickness underneath. All right. And so it'll create our mesh. Now we're going to create our major connector. So you can either do a clasp back here or a lingual apron. I like to make my major connector part of the rest. You could either do that or you could add it on later. I'll try jumping on the mesh. Sometimes I'll fill that in. Makes for a little easier transition. Let's do a little rest here. Now I'll do a clasp on the lingual. And then it's going to ask for the thickness. So let's, again, you probably don't have to go that thick, but we were going to go up to about 1 millimeter. Ooh, she freaked out on me a little here. There we go. That's a little better. We got going. All right, so our parameters are there. And so, when you design, you're making it a little thicker than the software's used to, so you can get little goobers and stuff like that. Not a big deal. I'm going to jump through this a little bit quick, but we'll mark our clasps. Again, we can go on the lingual. This is reciprocation, but you can gain a little of the undercut because this material is flexible. There's times where sometimes I'll make, the undercut on the lingual only, because on a lower sometimes that's all you can find is that lingual undercut. And so we'll mark our clasps. And so again, there's choices. You can see I made a VisiClear option. You can do anything. Let's say you don't have it. You can do a regular clasps, but then you can bring up your settings and you can make them bigger. So a lot of the software allow you to adjust some of that. So don't get caught up on, the clasp and making the clasp. You can definitely deal with some of those things and make sure we aren't touching tissue, or if we are, it's slight. We can always, again, adjust that when we get it out of the mill. That's totally up to you. And then you apply. And so that's, generally what I wanted you to cross with design, is making sure that you have enough thickness. Let me jump through here real quick. We'll start answering questions here in about 5 minutes. The cost of the material is right around $70. You can call, Zahn to get an exact on that. So that's a puck. You can fit, usually at least 2 partials in a puck for sure. Sometimes 3. I've kind of gotten lucky, and sometimes you'll have a small one and you'll be able to fit 3 in there. So, you figure you're looking at around $35 partial in material cost, but you got the crown and bridge side. And when you do those, you can definitely find that you'll fit little areas in there. Fit a little single 3-unit bridge, things like that, and you're taking your material costs every time you do that down. I got a bazillion laying around just waiting for temporaries to kind of come in, and so I can kind of fill those guys up. And I'll show you an example when we go back to the webcam of a nice case that's filled up a puck. So this is our finish line. This will be the last thing I'll kind of say on this. On the finish lines, I like standard 2 on this. Let me move him around. And the big thing here is I like to see a little bit of an undercut, right? So we get a little lock in there. So the acrylic, again, we have a acrylic that's solid, and then we have, the acetal that moves and flexes. So we want them to be locked together. Okay. So, here's our finished case. No, not really. We got to clean it up. And so, at the very end, it gives you your edit wax, and you can go through and smooth everything and make it pretty and take out some of these goobers that are in here and get rid of the stuff. A lot of times I'll kind of do that as I'm going along, but I just wanted to get the gist for you guys of kind of what's, what you'll kind of see as you go through. But I mean, I waxed that up in 5 minutes or whatever. And I would say generally it's going to take you about 15 minutes to do most cases. And, that's not bad. I don't know anybody who can wax one up that fast. Or actually, I probably do know some guys that can wax them up that fast, but that's not everyone, and we're losing those people. It seems like every day, sad to say, retiring and not in the business anymore. So generally, I can do a lot more to this, but generally we have our little unilateral ready to go to the mill. And I would support pin it on the tip, at the base, maybe one or two here, maybe one up here. I'd then, again, each tip, because that'll be flexible and you want that chattering on your burr. You can, on your tool, you can definitely break a tool. If you have too much flex going on, it'll want to kind of chatter on you. And next thing you know, you got that thing breaking on you, which isn't fun and not cheap. All right. So I'm going to minimize this. I am going to let you guys see my ugly mug again. All right. So questions. Let me pull up my little all right. All right. So we have a couple questions in. So it says, in a partial situation, can you build in full contour teeth where space is minimized? Absolutely. And that's something that you can really do, a lot with acetal because it's tooth colored. So let's say you have a situation where back in the posterior, you got, limited occlusal clearance, limited space. You can do a full contour acetal, Zirlux Acetal tooth as part of the frame. And it goes from being, if you had to grind a tooth down or do tooth-colored acrylic and fit it back there, it goes from being the strongest, the weakest to the strongest tooth on the whole partial. And depending on your software, Exocad, 3Shape, all of them, you can do that. And that's not too difficult of a process to bring that in. You can kind of design on your crown or bridge side, bring it in, or have a library in there and bring it in. Not a big deal at all. And I'll use that quite a bit. Even a little lateral. Let's say there's like a little sliver of a lateral. You can, put a acrylic tooth in there and it'll be gone in a few months. We all know how that is. We can make it part of the acetal frame and man, it'll be the last tooth standing on that partial 20 years down the road. Another question, do you mill wet or dry? Great question. Last time I did this webinar, you guys saved me with these awesome questions. You can mill wet or dry. I mill dry. My machine has the option of a wet mill option. Just do not do that. I don't find that it's necessary. Acetal mills like butter, and it just mills nice. Now, that being said, get some of these bigger mills and run them wet. You can kick those mill times down to like 45 minutes. They can really rip through this acetal, and the wet mill is a lubricant at the same time as a coolant, so it works really nice that way. So I mill dry, but you can mill wet. The OptiGlaze. So someone asked, will GC OptiGlaze bond? So yes and no. The OptiGlaze, the first thing people want to put it on is the major connector, do like a pink, and it will delaminate. It'll be a micromechanical bond. You'll etch the surface with air abrasion, but it will delaminate. It's the cool thing about acetal, we put a drop of crazy glue on it, let it set, you can flake it right off. And that's great for stains and bacteria and smells, but when it comes to adding a colorant to it, that's a limitation. And so here's my personal opinion on that. If you add it to a framework, don't. I would not. It's going to delaminate and fatigue, and it's going to go away over a short period of time. If it's a long-term temporary, 3 months or less, that'll work nice. So if you wanted to give it a little highlights, a little more incisal, translucency, under 3 months, I'm fine with it because there's not much flex to something like that. If it's going to be longer than 3 months, my recommendation, just shine up that acetal and let that nice characteristics of that acetal do its job over that long-term process. So someone asked, will acetal burn out during casting? I would not. There's going to be residue left. I'm sure there's ways you could get around that, but it's going to leave a residue and you're going to not like that when you go to cast and you find some porosities in your casting. So my answer to that is no, it does not burn out for casting. So someone asked about how the bond is between the duracetal and the acrylic. It's the same as it is between metal and acrylic. There is no real bond there other than the mechanical lattice work that you've created to lock the two together. So the nice lattice work being more robust is key to that, as well as that butt joint, the tagonal surface butt joint, as well as the occlusal surface butt joint is really key to making sure everything stays together nicely. Says, notice you had a visit clear clasp in the Exicad. What are you milling? So the answer to that, anyone in Chicago, there'll be some news on that. That's, a little bit of a, not something that's released exactly yet, but something that's kind of coming. So ask me about it in February again, and I can talk more. Or if you're going to be in Chicago, look for it, and I'm sure you'll find it. So someone asked the question, long-term temp, how long? So, I've had them in for a year, and in a year, it's really, I've seen them come back for patients, and man, they look like the day they were made. Again, doesn't absorb moisture. No moisture can get through to affect that prepped tooth on the underside. I recommend that if it's going to be in for 3 months or less, go ahead and use like a temp bond or acrylic or anything that they might use. The acrylic's not going to bond to the acetal, but I'll air braid the inside to give it a little roughness, and it'll stay in there nicely. If it's going to be in for 3 months or longer, I recommend using like a dual cure or even a flowable composite. Don't etch the tooth, or if the doctor does etch the tooth, just etch a small little spot on the tooth, and that will, give it enough grip that it'll last there for, the extended period, but won't fall off, on the patient on a regular basis. And I have a lot of surgeons that have me make these, materials, temporaries on these material, and, because they're having surgeries and they're going to be in for a long term, and they love it because they're like, man, I'll pull this temporary off, check how things are doing, put it back on. I'll do that 4 or 5 times in a year, and that thing just keeps going. So really nice option for the long-term temporaries. All right. So you guys can still post questions if you have. I'm going to show you a couple things. Here's one, and forgive me because this all works backwards, so I'm sure I'm going to be moving things around weird. But this guy here is a puck. All right. These are all samples, but this is a good, kind of realization of what you might run into. You have a night guard here, bite splint. You got a framework here. You got a little anterior 3-unit bridge there, a little Nesbit here. This could be all different combinations. You could have a cosmetic, appliance in here, different options. And, the way I figure this is anywhere from $400 to $500 worth of billing on this puck, depending on, how charges are, conservatively $400 to $500. And, so these pucks is at around $70. Again, confirm with your Zon rep exactly on pricing, but you're going to find it's right around there. Here's a little framework. All right. And so you can kind of see, this is a real live case. Here's the frame. You can see, you do have to follow some of the rules, right? So if you look at right here, I'm pretty high on the tooth here because the path of insertion, gosh, this is hard going backwards. I need to run high on the tooth. So this is a flexible material, but don't think you can just run them right down to the necks of the teeth. You have to be conscious of that undercut. And that's a cool thing with the softwares because they show you that undercut. It shows you what you're dealing with on that. Okay, we got a couple more questions came in. Says, are the pucks rimmed? And I believe he's talking about for mounting in the brackets, I believe, which they are. They're made to be mounted in all the more popular Rolands and VHFs and the mills that are out there. I believe that's the question you're asking. So someone asked if I prefer wet or dry. My experience is with dry, and I know it's okay. Wet, if you're running wet often, most mills, like my mill, I got to clean the heck out of that thing if I run it wet to jump back to dry. And so that's why it's a bit of a pain in the butt. I don't know for sure. I don't know how much faster you'll be able to mill when you do it wet. So it might be something for you to experiment with, run it wet, see what your times are compared to dry, and then you can decide whether it's worth your time. If you got a mill that runs wet, I think that makes sense. To be able to, and the acetyl's a lot like PMMA, a little bit better than PMMA, but it's a lot like PMMA in that you have the dust all over the chamber in there. It kind of statically charges and kind of attaches itself. And so the wet will kind of help control that a little bit. So that's a question I think that's more on you, but you can run it both ways, wet or dry. Find out what works for you in your lab. Here's a case here. This is on a sample model, but this is kind of one of the appliances that'll slide over. You can see it still has the support pins. I just snipped them off. I wanted to show you exactly how it comes out of the mill. And so I'm going to just sneak this guy off of here. As you can see, it has nice retention. This is a model I have I'm going to do for a sample, kind of showing broken down teeth. And then this guy just kind of drops down on there. And so when I would do these in the past, it was a bit of a challenge. You wouldn't see how nicely that material is adapting. And so they work nice. Again, they are not porcelain. They are not porcelain veneers. Make sure your doctors understand that. Make sure that you really get that point across, because you will have times, if you do not, where you'll do one of these appliances for the doctor. I'm talking about the cosmetic appliance, and they'll send it back saying the patient refused it because the patient was expecting something to look like veneers, and it's not veneers. So make sure that the doctor has realistic expectations, and that he, in turn, talks to the patient and make sure that they have realistic expectations, so everybody's on the same page. And sometimes I'll even, especially if it's bite opening, I'll mill out a PMMA version and send that like in clear as a try-in. And what that does is it makes sure the patient knows what they're getting. It also allows the doctor to make sure that the bite works for the patient. Allows them, they could even wear it for a while, and you want to charge for that. And then once they say it's a go, you just load that same file right in and run it through with a Zirlux Acetal puck rather than the PMMA that you ran it through, and that works out pretty good. But make sure you charge for it. So pricing, the pucks are right around $70. And so, I mean, the cosmetic smile, you could, charge anywhere from $400 to $500, even $600 if you're doing some preliminary try-ins and stuff. And you load 2 of those in there, and you're billing out, $1,000 to $1,200 out of a $70 puck. Well, that in my book, that's some profit to be made there. All right, so we're coming right up on the end. I want to thank everyone for tuning in. I know you guys are busy. I'm going to be taking these headphones off and walking out and sitting down on my bench and starting to do some work, just like you guys are. And I like it when people are trying to advance themselves. And please, in Chicago, come to the Zon room. They'll have a room set up with a lot of cool stuff. I'll be there most of the day. I'll also be presenting in that, I believe, in the Zon room, I believe is where the presentation is, on this as well. But if you have any questions, that room's nice. Down in the Chicago floor, it could be really hectic and you're kind of screaming over everyone. Up in that room, it's a nice, intimate situation where really, if you guys have some other questions, grab me and we'll sit down and talk and really, that's what we're there for. We're all, here to have a better time at doing this stuff. We're competitors to each other. We're in team together, I feel, a lot of the time, especially people who are looking to really advance themselves. All right, well, I'm going to sign off, and I appreciate your time. And look for any, some more. We might do some more that are more specific on some of these appliances in the future and some possible different materials as well. Thank you for your time, and I'll see you next time.